Hello and welcome back to Saxon Math. This is lesson 69, lengths of segments and complementary angles and supplementary angles. Letters are often used to designate points. Recall that we use 2 points to identify a line, a ray, or a segment. Below we show a line that passes through points A and B. This line may be referred to as line AB or line BA. We may abbreviate the line AB as line AB. You notice it has a line above it. It could also be written, line means infinity on both directions. It could also be written as line BA with arrows on the end to infinity in both directions. That means it's going to go on forever. The ray that begins at point A and passes through point B is ray AB, which may be abbreviated AB or ray AB. So if you're just talking about this point from A and then straight through B and on to infinity this direction, that would be considered ray AB. And it has to be with one arrow. It would just have one point and one arrow going that direction. You cannot have ray BA being the same thing. It would be the other direction. And it would start at B. So that's, you can't flip-flop the ray naming as you can the line naming. The portion of the line AB between and including points A and B is segment AB or BA. So if we were talking about just the points from this point to this point and everything in between, this is considered segment AB or segment BA. In the figure below, we can identify 3 segments. There's segment WX, XY, and WY. You can see that the length of WX plus the length of XY equals the length of W to Y. So in this figure, the length of L to M is 4 centimeters. From L to M is 4 centimeters. And the length of L to N, all the way from here, so from this point all the way over to this point, is 9 centimeters. So this point from here to here is 4 centimeters, and all the way from L to N is 9 centimeters. What is the length of M to N? So the unknown factor there is this point. We don't know what the length of M to N is as a line segment. What's the distance? Well, if you know that the total length of L to N is 9 centimeters, and you know that this distance from L to M is 4 centimeters, you know that 9 centimeters minus the 4 centimeters will result in the distance of the line segment M to N. So it's also this equation, 4 centimeters plus the length of that space, unknown space, L, equals 9 centimeters. Since 4 centimeters plus 5 centimeters equals 9 centimeters, that you can find that the segment M to N is 5 centimeters, just like this one would have been the length of M to N, or you could have named it M to N. They're the same thing, 5 centimeters. And that represents from this point to this point. So 5 centimeters. And if you look at it, this distance being 5 centimeters and this distance being 4 does add up to 9. We're also going to look at complementary and supplementary angles. Complementary angles are 2 angles whose measures total 90 degrees. In the figure on the left below, angle PQR and angle RQS are complementary angles. That's because this angle plus this angle makes a 90-degree total. In the figure on the right, angle A, angle B are both complementary because 30 plus 60 adds up to 90. And you notice this one is also a 90-degree angle. In a triangle, the angles always add up to 180 degrees. We say that angle A is the complement of angle B and that B is the complement of angle A because, again, they add up to a total of 90 degrees. So whatever the two angles are, they add up to 90. And that would be complementary. Those are considered complementary angles. Supplementary angles are two angles whose measures total 180 degrees. So below angle 1 and 2 in this case add up to 180 degrees. This distance or this measurement of this would be 180 degrees total. So that means this angle from here to here and then this angle from here to here adds up to one straight line, 180 degrees. Also, when you're looking at any plane figure, in this case, this quadrilateral parallelogram, you can see that angle B and angle C are supplementary because 105 plus 75 makes 180 degrees if you were to add those together. If we added 105 plus 75, the same with angle A and angle D, those are supplementary. You could also say that angle A and angle B are supplementary. You could also say that angle C and angle D are supplementary. They just have to have measures that add up to 180 degrees. So in the figure at the right, angle RWT, so R is right here, W is right here, T is right here. That means this angle from R to W to T between these 2 points, though that measure is a right angle, it says. So that measure is a right angle. Let's use the right angle symbol, which is more like a box. So in this case, which angle is the supplement of RWS? So they're asking, what's the supplement from here to here? Here's RWS. So that's this angle right here. Which angle is it? R to W to Q? Is it R to W to T? Is it S to W to T? Is it S to W to Q? Or is it T to W to Q? What angle is the supplement of RWS? And remember, supplement means it has to add up to 180 degrees. So if 180 degrees is the equivalent that it has to be, you have to look at it and say, well, if we've gone this far, if we were to include this point right here, we know that's 90 degrees. That's not a supplement, so we need to add to 180. A straight line is what 180 degrees is. So hopefully you can clearly see that from here to here, so this R to W to Q, angle RWQ would be the supplement to RWS. RWS is R to W to Q. That could also be named as angle QWR. Notice the vertex is in the center every time, but if we start at the Q, we can move our way this direction, W and R, it's still the same angle. If we went RWQ, it's still the same angle. Letter B, which one is the complement? So complement means it has to add up to 90 degrees. If it's R to W to S again, hopefully you can see that this angle right here, from here to here, would make that complement if we were to combine this S to W to T. So it's angle SWT creates a 90 degrees when added to the RWS. So if you're looking at the RWS, that's this one from here to here, and that makes that 90 degree angle, and that's what we're looking for. That could also be named as angle TWS, the other direction, TW to S. Okay. So let's try a few of these. In this figure, the length of AC, or segment AC, is 60 millimeters, and the length of BC, or segment BC, is 26 millimeters. Find the length of A to B. So from A to C, that's all the way from this point all the way to this point, is 60 millimeters. And the length from B to C, that's from this point right here, this would be 26 millimeters. And we're looking for this distance right here from A to B. So if I know the total length and I know this piece right here, that just means I'm going to take 60 millimeters minus 26 millimeters to find out that segment AB. All right, so in segment AB, if it was 30, it would be 30, but it's going to be 4 more than 30 away. So it's 34 millimeters equals segment AB. And I could check my answer by simply taking 34 plus 26, and it should add up to 60. 30 plus 20 is 50. 4 plus 6 is 10. That would be correct. Letter B, the complement of a 60 degree angle is an angle that measures how many degrees? Go ahead and answer that one. So remember, a complement is supposed to add up to 90 degrees. So if you already know what a 60 degree angle is what you've got, the angle should be a 30 degree angle. Letter C, the supplement of a 60 degree angle is an angle that measures how many degrees? Remember, the supplement has to add up to 180 degrees. So if we already have 60 degrees, we need another angle that will add up to 120 degrees, because 120 plus 60 makes 180 degrees. Letter D, if two angles are supplementary, can both be acute. Why or why not? All right, supplementary means it's 180 degrees. And if you're looking at a 180 degree line, that's basically 180 degrees. So if you're looking at this, and this is the measure, that's 180 degrees. If we were to split this, let's split it this direction. We've got one acute angle from here to here, and we have an obtuse angle from here to here. All right, if we split it another way, let's look at this one. Let's just split it straight up, and let's say this is 90 and this is 90. Are either of these acute? No, they're 90 degree right angles. Neither are acute and neither are they obtuse. Can they both be acute? The question is, well, let's try another one. Let's go this direction. Let's go from here to here. That's acute, but from here to all the way over to here is obtuse. So the answer would be no, they cannot be both acute. And the reason is the sum of both angles has to add up to 180. If one of them is acute, which is less than 90 degrees, the other one will have to be obtuse. And a 91 degree angle is obtuse. That is greater than 90 degrees. Letter E, name two angles in the figure at right that appear to be supplementary. So supplementary, again, remember that equals 180 degrees. So in this case, when you're looking at two angles, we've got angle 1, angle 2, and angle 3. This adds up to 90. Over here, it's unnamed. So the two angles that appear to be supplementary would be angle 1 and angle 2. because supplementary means 180 degrees. And you can see if you added this angle right here to that angle right there, that would be 180 degrees. Name two angles that appear to be complementary. So if you're looking at that portion of the question, you have to recognize that this is 90. This one is named already. If you were to add this angle and this angle, because this angle is 90 degrees, these two angles, angle 2 and angle 3, have to add up to 90 degrees because in a triangle, as I stated previously, the degrees of all the angles, and when you add them together in a triangle, add up to 180 degrees. So if this one is clearly a 90-degree angle, these two have to add up to 90 degrees. There you go. So there is your lesson. Make sure you look at lesson written practice problems 1 through 30. Remember, you need to complete practice problems 1 through 30 in order to get your daily practice and understand previous lessons. Have a great night.